So we are up to our last and final chapter, chapter 14, chi-square. So before we go through a chi-square test for independence, which is another example of a type of hypothesis test, let's just talk a little bit about what constitutes this type of test, and why would we be conducting this type of test. So just like we did in chapter 10 and 11, we were testing means and proportions, right? Certain parameters from the population. So now let's talk a little bit about chi-square. So we'll do a little bit of an intro. So a population can be divided according to different classifications, such as gender, age group, type of personality, marital status, religion, annual income, political affiliation, education, and so on and so forth. So these divisions are known as classifications of the population. And it's almost like what we're doing is we're categorizing, right? So we can divide certain people or things from the population into these different categories or classifications. So in this chapter, we're going to explore a technique that determines if two classifications of a population are independent, which would be unrelated, or little typo there, that should just be or without the E, dependent, related. So is there some sort of dependency or relationship between these two classifications? So here's some examples. So the first one says, are annual income and education dependent or independent? So if they are dependent, we would expect people with low levels of education to have low incomes and people with high levels of education to have high incomes. If they're not dependent, meaning if there's not a relationship, if they're not related and they're independent, then we expect people with high levels of education to have low incomes and people with low levels of education to have high incomes. Another example could be, are movie preference and gender dependent or independent? So if they were dependent, then the relationship between classifications might be that females generally prefer romance type of movies and males generally prefer adventure types of movies or action. But if they were independent, then knowing one gender would not give you a clue to their movie preference, right? So there would be they wouldn't be related in that way. So though that's where we're going with this. So we're going to be looking at two variables, and I shouldn't say variables. We're going to be looking at classifications, and we want to know, is there some sort of relationship? And going into it, so remember when we were doing hypothesis tests, whether they were on the mean or the proportion, the null hypothesis was always what we assume to be true, right? And we always go back to a trial. In a court of law, the null hypothesis is that the person is innocent. So in a chi-square test for independence, when we're gonna look at categorical data and see whether the classifications of a population are related, we're going to assume right off the bat that they're independent and that there's no relation. So in order to apply a chi-square test, we're going to take a random sample from the population and we're going to separate the data into different categories for each classification of the population. So there's going to be frequencies or counts or numbers. So there's going to be frequencies of responses falling into the different categories for each classification. And we display it in a nice table called a contingency table. And each individual box in the contingency table, we just call that a cell. And then the number within each cell is called the observed cell frequency. So it's what we observed when we analyzed the population and divided all our answers into these classifications, right, into these different categories. So what we have to do is, in order to determine whether two classifications of a population are related, meaning dependent, we need to compare what we observe, so the observed frequencies of the random sample, to the frequencies we would expect if there's no relationship between the two classifications. So again, we're always going to start off by assuming that the two classifications are not related, that they're independent. So we have to look at the differences between what we actually observed and what we would expect, assuming independence. Now, if these differences are small, then we would conclude that the two classifications are not related, that they're independent, because there would really not be much of a difference. And we're assuming independence going into it. However, if the differences between the observed and the expected frequencies are large, then we can conclude that the two classifications are related, that there is some sort of dependency. So what we're going to practice first is, let's just calculate some expected values. So I'm going to give you an example of what we observed, and then we'll use the formula for expected frequency and we'll practice these calculations. So what we do is, to get the expected value for each cell in our contingency table, we take the row total times the column total and we divide by the sample size. So let's do an example. So let's look at example 1. So example 1 says, a medical researcher is interested in determining if there is a relationship between adults over 50 who exercise regularly and low, moderate, and high blood pressure. A random sample of 236 adults over 50 is selected, and the results are given below. So the people in this sample that we took of 236 adults that were over 50, so we asked them about their blood pressure. Is it low, moderate, high? And if they regularly exercise or they don't get any regular exercise. We counted how many were in each classification, and we put the appropriate measures into each cell. So for example, 35 of these 236 people regularly exercise and have low blood pressure. 21 people were observed to not regularly exercise and have low blood pressure. 62 people regularly exercise and have moderate blood pressure, and so on and so forth. So that's how we interpret this table. So each one of these values in this table is an observed value. So it's what we observed when we sampled and asked everybody what their classification is. So I'm just going to use O for the observed value. So that's what this O stands for. So if we were to sum up all these rows and columns, we should get 236 as our total, right? So sometimes it's nice to get the row total and the column total. Which I'll just add right here. Sometimes it'll be given, sometimes it won't, but we could easily just add these in here. So if I were to add up the first column for low, we would get 56 people. For moderate, we would get 127 if I were to add those observed values. And if I were to add for high over the regular no exercise, we would get 53. So now if I were to do the row total, so if I were to add across all the people that regularly exercise, we would get 122. And if I were to add across the people that don't regularly exercise, so if I were to add up the second row, we would get 114. And when you add up all the column totals and all the row totals, we should get 236. And you could always pause and check that yourself with your calculator. Okay, so all I did was add the row totals and the column totals and the total, which is 236, which makes sense because that's what we started with. So what I want to do is, let's calculate the expected value of each cell. So this is an example of a contingency table. And each one of these boxes that has an observed value, it's just called a cell. So we have our observed values here, but let's calculate the expected value. What would we expect? How many people would we expect to be in each cell assuming these classifications are independent of one another. So the way we get the expected frequency is we take the row total, we multiply it by the column total, and we divide by the sample size. So for example, let's get the expected value for this first cell that I just starred. And you know what? I'll do these in red, so they're different colors. So the first expected value, so if we take the row total, so I'm going to calculate the expected value for this cell right now. So take the row total, which is 122, multiply it by the column total that it's in. So it's in this column. So the column total is 56. And then we divide by the total sample size, which is 236. And then we're just going to round appropriately. So this rounds to about 29. So let's just go to the nearest whole number. So this works out to be about 29. So the expected value, so what we would expect if blood pressure and status of exercise were independent, we would expect about 29 people to fall into those categories. So let's keep going. Let's get the expected value for people with low blood pressure and no regular exercise. So for this cell here that I just checked off. So we're going to take the row total, which is 114, and we're going to multiply that by the column total, which is 56. And then we divide by total, which is the sample size, and we end up with about 27. So I'm just going to put approximately, because we're rounding a little bit. These are all going to be rounded values. So we would expect 27 people to fall into this cell for low blood pressure, no regular exercise, if blood pressure and the amount of exercise were independent, if that assumption was true. So for the next one, for moderate and regular exercise, so we're looking at this cell right here. Let's get this expected value. So we're going to take 122, the row total, times the column total, which is 127. And we're going to divide by 236. And we get about 66. So expected value would be 66. For the one underneath, let's get the expected value. So row total is 114. Column total is 127. Total sample size is 236. And we get about 61 for the expected value. And let's get those last two cells. So we're going to take 122, the row total, times the column total of 53, divide by 236, and we get about 27 for the expected value. And then let's get this last expected value. So the row total is going to be 114. The column total is 53. We need to divide by 236, and we get about 26. That would be my expected value. So the purpose of this is to see how big the difference is between the observed value and the expected value. Like, look at this first cell, for example, that I just highlighted in green. We observe 35 people to have low blood pressure and regularly exercise. But if blood pressure and exercise status were independent, then we would expect about 29 people to fall into that classification, into that category. But there was 35 actually observed. So is that are they close, 29 and 35? In other words, is there a big difference? So overall, for all these cells, if there's independence between the two classifications, the observed and the expected are going to be very close. If there's huge differences overall, then we're going to think, okay, maybe there's some sort of dependence. So that's what we're going to do next. So next, what we're going to do is we're actually going to compare the observed to the expected, and we're going to calculate a statistic that's going to help us determine, if there's going to be independence between the two classifications or some sort of relationship. So we'll continue this in the next lesson.